Okay, good day, everybody. My name is Achoyim Chidera, and today I'll walk you through the real-world cybersecurity applications using Kali. And these labs go beyond theory; they reflect what analysts actually do in the field. So the topic today will be real-life applications as a cybersecurity analyst concerning defense. Okay, so the first thing that we're going to talk about is why Kali named Linux for cybersecurity. So I'm going to mention four various reasons why Kali Linux is preferred for cybersecurity. Now, the first reason is comprehensive toolkit. So it's pre-installed with 600 plus penetration testing tools. Example, Hydra, that is for online attacks on brute force, Nmap, which is for scanning, John Ripper, which is for offline brute forces, and etc. There are many other penetration testing toolkits. Another reason is because it's preferred by professionals. So it's used by red teams, like SOC analysts and ethical hackers. Another reason is because it's lightweight and it's flexible. So it has an optimized environment for security tasks and automation. And the last reason I'm going to mention is analyst goal. So it performs reconnaissance, threat analysis, and automates defenses. Next thing we're going to talk about is how to get started with Linux. So the first thing you do is you set up your Kali. You can install your Kali in a segmented testing network. Next thing you do is verify system info. So you use commands like check kernel, hostname, and network interface. These are various commands that you can use to like verify your system information. So uname -r is to check kernel version. There are various kernel versions, so you check yours. Um, Hostname CTL is to view host OS details. IPA is to view network interface setup, and then the next thing you do is to isolate the network. So ensure lab safety without risking production systems. Next thing we're going to talk about is text manipulation. So text manipulation is basically a tool in log analysis, or basically in scripting for Kali Linux to make work easier for you. It also helps aids in automation. So just to help identify things. So if you had a log file, right, you can use text manipulation to extract information that you want specifically from the file without wasting time going through it line by line. So in this scenario, we're trying to investigate field logging attempts from unknown IP. So the use case is pass VAR log or the log for brute force or lateral movement detection. So in a scenario where somebody is trying to crack a password but doesn't have the correct password, the and you have an SSH service running. So if this SSH service was running and somebody was trying to crack a password, I mean trying to like log in without the correct password, it will be recorded in the auth.log file. So this is where everything is recorded. This is the location VAR. Sorry, this is the directory VAR log auth.log. So this is where it will be. Now, in order for you to maybe you want to go there and identify what you're trying to do is investigate the failed login attempts from unknown IP. So obviously there are people that are trying to log into your system, right? It's recorded, and as it's recorded, if the IP address, I mean, if the password they're trying to put is not correct, it will show that it is a failed attempt. It will say failed attempt from this user in the log auto log file. So how can we identify the IPs from there? The first thing we do is we can use tools like grep, right? Grep is to highlight specific words from a file. So in the scenario where we're trying to get the field attempt, you can highlight field, right? Awk is also a tool that we use. Awk is to highlight is to extract columns. So imagine this is a line in the file, right? This is column one, this is column two, this is column three, and so forth and so on. So Awk is a very useful tool. Source is used to arrange it in order. Unique is used to identify. Let's say the same IP has tried to crack your password 10 times, right? Instead of you seeing that IP 10 different times, it will just show that it has done it. this IP is part of them, so it's unique. So you cannot, it's not two of the same. It's just one that will appear. So the result is early signs of intrusion to repeated login failures. And yes, this is the command that we're using to do this. So we grep field password, obviously. Field password will be what you'd see in the auto log file if somebody's trying to brute force into your system. This is the location of this is the directory. Print awk print $11 is to print the 11th column, and then we sort, and then we use unique -c and sort -error to organize the IP addresses that it has identified, and then put it in order so that you know the one that has done the most. So by analyzing the authentication logs, I identified which IPs were making repeated login attempts, a key early sign of intrusion. Next thing we learned about is securing SSH access. So SSH stands for secure shell, right? And SSH is also a service. So the reward scenario that we're talking about is securing SSH service to prevent unauthorized remote access. And the use case is configuring SSH to use key-based authentication and disabling root login. So we're trying to change we're trying to prevent unauthorized access, right? And one way that we can do this is by configuring the SSH to use key-based authentication and disabling the root login. So the commands we are using is sudo nano etc. This is the configuration file, right? And in this file, you can change certain things to change the permissions, all of that. So we're trying to set permission root to no and set password authentication to no. And sudo system restart SSH. So this will completely restart the service. So SSH is a high value target, and I hardened the access by eliminating weak password authentication completely. Now, this is done to improve the security of your service and prevent it from being intruded. Right. The next thing we're going to talk about is scanning with Nmap. We learned about scanning with Nmap. Nmap is a very important tool or useful tool for scanning. Right. You can scan a target IP, or you can scan a range of IPs. So you can scan multiple IPs at the same time, and you can just see what is happening around. So scan network. We use Nmap to scan subnets for open ports, right? So we're trying to find open ports, and then next thing we're trying to do is identify vulnerabilities. And this is just what Nmap does, right? So in a scenario where you're scanning a specific IP now, this IP, what Nmap does is that Nmap checks for open ports and sends looks through this thing to identify vulnerabilities and look for the open ports so that you can be able to secure your systems, right? So you detect outdated services that attackers could exploit, and then we use Nmap to scan the subnet for open port services. So once this Nmap identifies the open ports, what it does is it strategically sends requests so that it can check for vulnerabilities on these open ports and look for which ports are open. So that's basically what Nmap does. In this scenario, we are using the range 192.168.56.0/24. So it's to search for all the IP addresses in this subnet. I mean in this octets, right? So remember there are 205 IPs in here. So we're using Nmap and -sc and -sv. So this is basically to check for, this is basically to add that flags, to add more details in the scanning that you're trying to perform, right? So once you do that, you can see that there are some open ports, and basically this just helps to check for vulnerabilities and look to know around what's happening in around your system and like in the services, right? So using Nmap, I scanned the lab subnets and found an exposed web server with an outdated PHP version, which is a common attack vector. The next thing we're going to talk about is offline brute force attack. So brute forcing is basically a trial and error method of that attackers use to gain your credentials, like your password, to get your credentials like your password or your username, things like that. What it does is just basically repeatedly trying new passwords to gain access into your computer. That's why it's good to have auto log policies, right, to prevent attackers from gaining access into your system. So the scenario that we're using in here is testing password strength using offline hash cracking. Use case we're auditing passwords, password security leak in password security in leaked etc/shadow hashes. So etc/shadow hash, sorry, etc/shadow is where the hash file for every user in the system is found. So I mean, this is the um hash code, like the hash for, let's say you have multiple users in your system. Let's say there is a user named Kali and there's a user named Chidera. So there's a user named Chidera, multiple users. If that user has a password, then the password is stored in a hash format in this location in the system. So if this gets leaked, then it can be cracked, right? Now we're using a word list. So we apply popular list known as rocku.txt. Rocku.txt is basically like a file that has a bunch of combination of numbers, random words, and just popular passwords that people use. So if you use weak passwords like 1 or 2 or chidera.123, things like that, it's easy to be cracked, right? And we can also create our own word list using Crunch. So Crunch is also a tool to create word lists. There's COP, there's Sewell, all of that. You can use it to create word lists of your choice, right? And then review weaknesses. So passwords like 53124 crack quickly, indicating policy gaps, right? So if we use John, because John the Ripper is what we're using to perform this brute force attack. So if we say John crackme.txt and word list equal to crack pass dot txt format script. So I input the, keep in mind, our password got leaked. The hash format for our password got leaked. So we input it into a different file, and the different file is called crackpass. Sorry, the different file is called crackme.txt. That's what we want to crack, right? And our word list, we created a word list, right, of a bunch of combination of numbers. So this is the word list that we're using to crack this file. And then crack the hash, and then obviously the format. So the format is script. So this is basically the way that it's organized in order to crack password. And this is how some attackers do it offline, right? So 53124 is the password for CrackMe. Now, password cracking reveals policy weakness. So if 53124 gets cracked in seconds, then we have a problem. Now, how can we mitigate this? We can mitigate this by um using stronger passwords. One, you can also employ lockout policies, like say that if somebody tries to log in more than a specific number of times, like 3 times, if they try 3 times, then they should be locked out and be informed to know that, oh, somebody's trying to gain access to your device. So those are the ways that you can prevent all of these. Now we talked about Linux scripting. So Linux scripting is basically essential for automation, right? Automation is a very important part of the cybersecurity personnel or engineer or analyst. If you keep on doing the same task repeatedly, we're trying to keep in mind, we're trying to save time. So if you keep doing the same task repeatedly, then there is no level of efficiency or effectiveness in your work, right? So we're trying to make everything work fast for us. So Linux scripting basically helps in automation. We want long, boring jobs to be done quickly, right? So in this scenario, we're trying to automate cleanup. So we write a script to archive logs weekly and clear files. And then also we schedule scripts to run regularly without manual effort. And we improve performance. So we reduce noise and keep the system performing smoothly, right? So what happens is there is a host.log file that obviously um records things happening in the SSH. So this is where the SSH is being logged, right? And what we want to do is we want to keep in mind, we want to write a script to archive the logs, right, weekly, so that you will not have to like be looking to it every time and look for when this happened and when what happened. So you just want to put it in a new file weekly, and so that you can go back to the file and say, oh, this happened in week this and this happened in week that. You understand? So if we say tar -c -z and -f, this is for to create a bundle, this is for archiving it, and this is for naming the file. So this is to add the date to the name of the file. So it can be 2024, the 21st of April, right? This is just add the current date of the file, and then this is truncate. So this is basically delete the file without actually deleting all the information in the host.log file, and then it's just record a new one. So once you do the scripts like this, just save hours, right? For analysts so that we don't spend time doing repetitive work. Now, Wireshark. Wireshark is a tool used for network protocol analysis that is used to analyze packets of data traveling across a network in real time, right? A packet is basically small pieces of data or information, right? And Wireshark is basically the tool that we use to capture these packets, right? And we can analyze and gain information from it. So in this scenario, we are detecting data exfiltration using large outbound transfers. And the use case, we are filtering a PCAP file for abnormal traffic patterns. Okay. So a PCAP file is basically a Wireshark file, so that if it's like a file that contains stored network packets that were captured. So in the command example, we're using tshark. So this tshark is used in your Kali. You have to put this in order to run it in your Kali. Wireshark is also an application that you can install, but if you want to run it to your Linux, like directly, you can use this and then include all these flags. So tcp.length is to find the ones that are the length that are over 1,500, and then the IP destination of the destination of the IP address is 192.168.1.10. So this basically shows large packets going to a suspicious IP, right? And suspicious IP here is the name of the file that we're trying to analyze. So basically, Wireshark is just useful to analyze and gain information from captured packets that were just stored, right? So if you want to see if somebody is trying to gain access into your device or whatnot, or you're being spoofed, like ARP spoofing, you can filter things. You can filter ARP, and then if you notice that there are in the same line, there is the same MAC address appearing twice in the source and the distance, then you know that somebody is spoofing, right? It's called ARP spoofing, and obviously you're trying to like gain control of your system and just gain information or do whatever they want. And obviously, Wireshark is a useful tool to identify it. You can also use it to troubleshoot on problems like if you can't ping on your system, you can filter ICMP and just view what you're seeing just view the things that are going on in your system. So if you ping something and you filter ICMP and you look to it and you see that you can see the request but you cannot see a reply, then the fault is probably from the IP address that you're trying to ping, right? Maybe they are shut down or there's a network issue from their end. But if you cannot see any reply or any request at all, then you will notice that, or maybe it is your own network. That's the problem. But moving on, we learned about understanding the TCP and the IP model. So the TCP model is a framework that describes how data is transmitted over a network, and it has 4 layers, right? Each layer it has specific responsibilities. So it goes from bottom to top. There's the data link layer, there's the network layer, there's the transport layer, and there's the application layer. So layer by layer troubleshooting is key to diagnose and fix real network issues. So if you have a network issue, you go layer by layer to identify what the problem is, know how to fix it. So a good analyst sees full stack layer by layer. Troubleshooting is key in the real world environment. So in each layer, the data link layer basically detects spoofing using ARP-A. So you can view ARP table in this data link layer. The network layer basically is for verified routing via trace routes. This inspects handshake using TCP dump. And then application layer basically checks DNS latency with DIG. Next thing we're talking about is online attacks using Hydra and Medusa. We already talked about offline brute forcing. There's also a method of attack online, right? And you can perform this using Hydra. Hydra and Medusa are tools that can be used to perform this, right? So online attacks are cybersecurity threats where the attacker must interact with a live system over a network in real time. So they involve direct communication between the attacker and the targets, usually trying to exploit vulnerabilities immediately. So in this scenario, we're testing login portal resilience against password attacks. And in the use case, you're assessing local thresholds by launching controlled brute force attempts. So I'm going to explain it to you using this screenshot right here. So Hydra-L. Hydra is obviously the tool that we're using, and -L is a flag to mention the user that we're trying to attack, name of the user we're trying to attack. We do -P for the word list. Keep in mind we're brute forcing, so you need a word list. You don't know the password, so we're trying to get the password, and we're trying to guess the password from a list of passwords that we are assuming that it might be, right? And then we say -F, we put SSH, and then we put the IP address of the service, right? And then you can see here that we can crack the password, and the password is 1. Easy password like 1 are not acceptable if you're trying to actually like hide proper information. Another way to do it is using Medusa, right? Medusa is also a very useful tool for this. -U is for putting it's basically the same format. If you notice here, it says -L and you use for which name of the user that we're trying to attack. Well, you say -U and testing the name of the user that we're trying to attack. So we use the password list. So testing password list. -H is for the host's IP, and then this is for the service that we're trying to attack. So the service here is also SSH, right? This -U, if you put capital U, keep in mind the capital and the small letter are important. If you notice -P here is capital, -U here is small because it's one user we're trying to do. If we are trying to do multiple users in a file, we do capital U and then put the name of the file here, and you just crack the password. Next thing we talked about is introduction to Trojan. So a Trojan is a type of malware that disguises itself as a legitimate or harmless program to trick users into installing it. The difference between a Trojan and a virus or a worm is that Trojan does not self-replicate, right? So once installed, once this Trojan is created, right, it is going to be executed by what the attacker wants is that the Trojan gets executed by his victim. So once his victim executes this file, right, the attacker can now gain access to your device and just see whatever he wants. He can view your webcam, he can record, he can look through your files, all of that, right? And there are 2 ways to do it. There's called the bind method and there's a reverse technique. All of those, yeah, those are the 2 main ways to do it. And the reverse technique is more popular, and I'll tell you why. In the bind technique, after the victim runs this file, the attacker can now after the victim runs the file, the attacker will have to connect. So the victim's device will become a server, and then the attacker will become a client. Now, in order to do this, the attacker has to be in the same network as the victim. But in the reverse technique, once the victim runs this file, right, or runs this executable program, this Trojan, right, the victim now calls the attacker to connect. Now the attacker has access to the file. Now, why is reverse like easier? Because you do not have to be in the same network as when you're using the bind method, right? So once you use the reverse, there's no need to be in the same network, and being in the same network can be a hassle. So in the scenario we are going to talk about is after noticing unusual outbound connections on firewall, a SOC analyst suspects that the user's Kali 906 system may have being compromised via a Trojan that establishes a reverse shell to an attacker controlled service. So the use cases we're identifying and analyzing suspicious processes and open network connections to confirm if a reversed shell is active. So the key commands that we're using in this is ps-ox and grep-nc. This is basically to detect netcat reverse shell processes. We're using netstart-antp, and we are grepping established to list active TCP connections. We are using LSOF -I 444 span processes. on attacker's IP, on attacker's post 444 because post 444 is usually the most common one. So after the firewall, alerts flag the normal outbound traffic. I use Kali to investigate running all of these, and this is just how you can resolve it and just know. So firewall defense with UFW. A firewall is basically a security device, and it can be hardware, software, or both that monitors and controls incoming and outgoing network traffic based on a set of security rules. So there are basically rules that the firewall follows. It's a barrier that basically stays between trusted internal network services and untrusted external network services, and just follows a strict set of rules, right? Now, the purpose of this is that it acts as a barrier between a trusted network, right, and untrusted networks. I just said that, and it helps block malicious traffic and prevent unauthorized access to systems. So in this scenario, we're trying to restrict network access on a new system using UFW firewall. And the use case, we align only SSH port 22 and HTTP port 80. So block all other traffic. And the command is to set default deny or for incoming, sorry, and allow 22 TCP and 80 TCP, then enable UFW. And then the best practice is follow a strict deny by default rule, which is keeping only essential ports open. We don't want any ports that is not being used to be open because it's not right. Now, the lessons learned and challenges faced. So the challenges I faced throughout the course of this, throughout the whole course is basically understanding very log syntax and finding stealthy threats in packet capture. Another is debugging bash scripts. So troubleshooting cron jobs and scripts errors was complex, but it was essential. Next thing is the key lesson. So you want to learn how to automate tasks, document thoroughly, and think like an attacker and a defender, right? And reflection is that this course sharpened technical and investigative skills for real SOC work. So this course sharpened both my technical and investigative skills, and now I feel more prepared to work in a real SOC environment. Thanks for listening, and feel free to ask about any technique tools or use case covered. Thank you.